One very nice and I would say unique feature which we have in Comosys is something what we call the Design Evaluator. And now in design, normally because of all this color coding and this and that, you can get a design in which everything is green. So you turn on the color coding and everything looks green and blue and yellow and the colors look nice and there's nothing red. And it would seem that, you've got a very nice design. But the reality is that you can get all your colors to be green, and there could be many reasons why the design would not be considered to be a good design by an experienced designer. And there are many reasons for that. Now, when somebody brings me this model after having worked on it for a month and gives it to me and wants my opinion, if I turn on the color coding, I really can't guide them much in 10 minutes. I mean, obviously, if something strikes me as very abnormal in the first minute, then I can. But actually going through every single floor and the way they have set up their horizontal bracing systems and the way they've set up their vertical bracing systems and what maybe things that an experienced engineer would have done differently, but that would require me to actually sit down and work on this model for a day or half a day or some time, and then come up with my suggestions. So we have developed something called the Design Evaluator for that. And what you do is you simply select the model and you go to your Design Evaluator. So imagine this model has been given to me by a young engineer, and ask for my comments on it. I just press OK, and this fills up this Design Evaluator form. My whole purpose right now is to spend 10-15 minutes on this model and give the fresh engineer some feedback. So the first thing it does is it gives me a breakdown of all the columns and beams and vertical bracings and horizontal bracings and girts and purlins, how much they are by weight. So the columns are 53% by weight, the beams are 31% by weight, the vertical bracing is 13%, and what these numbers. And I can also see how the columns are generally failing. The normal stress ratio is averaging around 0.57. The lambda ratios are averaging about 0.118, and deflection ratios as well, because we haven't done the deflection checks on the columns. The overall drift check is obviously different. But more than that, although this gives me some idea, but more than that are these two over here. And these are typical areas where fresh engineers will make mistakes. So for example, what I don't want is a lot of my elements failing because of lambda criteria. So my lambda, let's say I don't want my lambda to be greater than, say, 150 or some number. 130, but they have designed it in such a way that a lot of my elements are failing because of lambda. And they would pass if they increased the lambda, decreased the lambda and chose a higher section, the element would pass. But that's not something what I want. What I want ideally is for all of my sections to be approaching 1 as far as the normal stress ratio is concerned. Because that represents optimal use of material. I don't want to have my elements failing because of lambda or deflection. Now, sometimes they have to, but that's not something I want. So this one quickly shows me that I've got 4.12% of my elements which are failing because of lambda critical frames. And what I can do is I can say fill, and because I don't know which one these are, and this list is populated, and then I can select anyone and say go to, and it'll take me to the model and show me exactly what's happening over there. The other thing I don't want over here is deflection critical frames. It says about 3% of your elements, which is fine, and this is not a bad design. I'm just giving an example that 3% of my elements are failing because of deflection. If I press fill over there, this list is populated again, and I can then press go to and go to those individually and see why is there something I could have done differently. Maybe I could have framed them differently and get a better design. Similarly, what I don't want is shear critical elements. I want my elements to fail because of normal stress or bending stresses, not because of shear stresses, typically. So this number is reasonable again, only 1% is failing because of shear, or if shear is governing, I should say, not failing. And 91.744% is the normal stress is governing, and that's a very good sign. So this is a good design. But over here, we see that these are floor beams. And in floor beams, you want basically your floor beams to be dominantly loaded in the M33 direction. So because of their three components, the axial component, the M33 component, and the M22 component, for the floor beams, I want M33 to be dominant. I don't want M202 to be dominant for the floor beams. But this one is telling me that about 8.65% of your total weight of beams has got a very high M2-2 ratio. So I'm interested in that. Let's press the fill button and go to this one over here and see that, okay, this one has an M2-2 ratio of 0.449. That's very high. I want this one to dominate. So what I'll do is I'll select this one and say go to, and it takes me to that beam. And if I actually open it up, if I open up the design data, I see that yes, actually the bending 2-2 component is actually dominant, and that's not something I would have liked. So I can then take a look at it more carefully, and it's probably because of these horizontal bracings over there, and they're really pushing into it in a lateral direction. So maybe that will give me an idea about what I can do with that, or what I can suggest, because this is a waste of material. This is not a good way of using this. What the program has done is, because the loads are in the M2-2 direction, it has optimized this section by just using a bigger and bigger section. But that's not good. I could have chosen a much smaller section had my lateral loads not been there, or if I had used a different section, maybe a different type of section, maybe. Another thing which I don't want is for my bracings, say my vertical bracings or my horizontal bracings, to be failing or having a significant component of moments in their design. I want them to be primarily working for the axial loads. But you know, sometimes when we have these large bracings, even their self-weight can cause bending moments. And sometimes if they're not supported along their self-weight, that bending moment can take up a lot of their capacity. Now, in this case, we don't have any of those, but there's a limit over here. I think it's, let's see, where for axial loads. So it's 0.3. We don't want a limit for ratio of priorities for the direction, so that you can change these numbers over here. So yeah, this is the one. I'm sorry. Upper limit for some of the moment ratios for profiles whose primary intention is to take axial loads. So yeah, I can reduce this number to 0.2, for example, and I can see which ones are failing according to that. Then I have this lambda max over lambda minimum limit. This is also important. Obviously, every profile will have a weak direction and a strong direction, and there will be a lambda max and there will be a lambda min. And typically, I would want these two numbers to be close to each other, because if lambda max is much bigger than lambda min, then it's obviously going to fail in the lambda max direction, and that's going to be a waste of material. So this is over here, this is lambda max to lambda min ratio 1.2, which I've specified on the right hand side. And over here, it's showing me all the elements in which the ratio is greater than 1.2. So I can zoom in on those and maybe suggest something to the engineer that don't do it, or put some zero members in that direction or something like that. So these are things which fresh engineers miss. Lambda related criteria, deflection. In the end, they get everything green, and that's okay. But that doesn't really mean the design is good. So you can have lots of elements failing due to deflection. You can have lots of elements failing due to shear. You can have lots of floor beams in which M2-2 is dominant. You can have bracings failing because of moments. If I were to just take a look at the color coding, I would think, okay, this is a reasonably good design. But my whole idea is to spend 10 minutes, 15 minutes, and give the person some sort of feedback which they can use to modify the design, because you can have everything green and still it could be a horrible design. So this design evaluator is a very nice feature which you can use to quickly go through as a senior engineer in the company, because when your junior engineers will be forwarding you their models, you can go through them in 15 minutes, 20 minutes, half an hour, and give them a lot of nice comments which they can use in their refinement of the analysis.